In the next few videos, we will start talking about sines and cosine are periodic functions or sinusoidal functions, and we're going to talk about moving them around and talking about what happens when we start messing with the numbers on there. Okay, the first thing that we're going to start focusing on is given functions, right? So this is how it's going to look. There's our sine function. Looks like this, right, with all the letters there, and we'll talk about each one of these letters in the next handful of videos. Okay, the first thing that we're going to focus on is what do we get from the b. So the b here, so the b, there we go. Take that b, and it's going to actually tell you the period of your function given if that b changes. That number is actually what affects how long it takes sine or cosine to get through their whole period. So the normal period for sine was 2 pi. And now we have a new formula here. If I want the formula of something that's been messed with, right, where that b changes, I just take 2 pi and I divide it by the absolute value of b, meaning the period is just always going to be positive. It's a measure of distance. So we take its period, 2 pi, and we divide it by the number in front of x. So let's take a look at something, a few functions that are simpler in nature, not with all the a, b, c, and d there. So take a look at this sine function in our example. So this sine is pi over 6. So b in this case, if I were to pick up b is equal to pi over 6. Pi over 6. So if I want this period, I'm going to take 2 pi, and I'm going to divide it by pi over 6. Okay, notice the pi's are going to cancel. And if you plug this in your calculator or flip your fraction there, you're going to get a 12. So the period for this is 12 units. What that means is that it would take 12 units, and we could even see where these are going to go through. We just cut them in quarters. And we could see that our sine function is going to look something like this. I plot above, on the midline above it, on the midline, below it, and back on the midline. So it would take, instead of it taking 2 pi to get through, which is about 6, it's going to take 12 units to get all the way through our sine function. All right, consider this cosine function over here. So g of x, I'm going to rewrite it just to shift our focus. And I want to rewrite that x over 3 to make it look like that last problem. This is actually 1/3 x. So period, well, let's write b. b for this problem is 1/3. So the period for this cosine function is going to be 2 pi divided by 1/3, which is going to be 6 pi. So we took our period and we multiply it by 3. So this cosine, let me show you what it's going to look like now. It's going to go all the way through 6 pi. And how I do this is I start 0 to 6 pi. I cut it in half, 3 pi. And then each one of these I cut them in half, 3 pi over 2. And then let's make sure we're doing this right. Half of 3 is 1.5. So this is going to be 4.5. I'm going to be a little lazy and use the decimal here. I guess we could use 9 over 2. 9 over 2 pi. There we go. So this cosine function is going to look like this. Cosine starts above, goes down, all the way down, back up, all the way back up. So there is my cosine function given this period is spread out across 6 pi. So as you can tell, if you put a fraction in front of b, the period's going to get longer. So I would, if you were considering, put a 5 in front of it and go ahead and figure out what that's going to do. This is also a great time to take these and plug them into Desmos, meaning like take this thing, look at it, come up with your period, make sure you think you know what it's going to look like, plug it into your grapher, and make sure it does.